right, we're starting with Unit 4, Composition Functions. This one should have 2 videos. This is my first one of the second one. Composition functions are basically when we take 2 functions and fuse one into the other. And the order in which the fusion is done matters, because the answers are going to be totally different. And let's look at some examples. Well, before we look at examples, let's see how it's written. This one is read as f composed with g of x, or f of g of x. They both mean the same thing. They both should have the same answers. Either way, if you notice that g of x is the second one, or g of x here is on the inside and is the second one. The second one is what is grabbed onto and fused into the first one. G of x is what we will grab and fuse into f, and that terminology is called composition functions or composite functions. That word automatically should remind us that one function was taken and fused into the other function. Fuse is the word that I use. It's not a technically correct mathematical word, but we always use words here and there to kind of remind us or help us remember concepts. Let's look at this first example. Please register there's a function f of x and there's a function g of x. We have 2 functions and we have 4 parts to it. First one wants us to do f composed with g for x value 1. Please notice that this is the x value they want us to use, whatever is in the parentheses. So as I said earlier, the second function is what needs to be evaluated first or grabbed and fused into the other one. Since the x value is given, I'm going to first evaluate g of 1. And obviously for that I need the g function, and I'll substitute 1 for all x's. Wherever I see x, I'm gonna substitute 1 in there. 1 to the third power is 1, so this boils down to 5. Now if you notice, what happened here is that I already evaluated g of 1 and the answer to that is 5. So now I need to find f of 5 and that will give me my final answer. And again, to evaluate f function, I need to get my eyes on the f function. 2, and all the x's will be replaced with 5. This is 53. So my final answer, f composed with g at x value 1 is 53. Look at the next one. This is g of f at the same x value. So the only difference is the order, and you will see that the answer changes. The first we will have to evaluate f of 1, and for that I need f function. Now that I have the baby function evaluated, I need to find g of 5 now, and for that obviously I need the g function. When you evaluate this, it turns out to be 501. So this is g composed with f at x value 1. If you notice this, only the order mattered, but see how different the answers are. Okay, let's try C, and I'm going to ask you to try G on your own. This one's saying f composed with f, so f needs to be fused into itself. First I'm going to find f of negative 2. F of negative 2 turns out to be 11. And now since this needs to be fused into f itself, now I need to find f of 11. So this was first step and this is second step. This is 121, 242, so 245. So f fused or composed with f at x equals negative 2 is 245. Okay, now go ahead and try D. All right, now we're going to do the same thing. We're going to still evaluate fused functions, but instead of equations, we're going to use graph for it. The rules are still the same. You're going to look at the second function first. You got to evaluate that first. And again, whatever is in the parentheses, that is the x value. So I need to find g of negative 7. So I'm going to go at negative 7, be right here, and then go towards g function. G function is the red one. F function is the blue one. So from here, I'm going to go towards the g function, red one, and get the corresponding value, which is 5. Okay. So all this part, the pink part, is actually 5. Now I need to find f of 5. So So I go b at 5 and go towards the f function, which is the blue one, to get the corresponding value of 5 there, which is 4. So the final answer is 4. Let's try again. Same function. We have to find f of g of 5 or f composed with g at x equals 5. So no matter how I write it, you have to find g of 5 first. You go here and go towards the g function, which is the red one. Get the corresponding y value, which is -7. Now I need to find f of -7. And the f value will be the blue function, so keep going, and the corresponding value is 10. So my overall answer for this, the question, is 10. 10, same answer. Now go ahead and try this one, same graph. All right, the other thing we wanted to know is how to find domain and how to fuse functions when x value is not given. Okay, so no x value given, you have to use the entire function as such. For example, if you look at this, f function is given, g function is given, and they want me to find f of g. If you notice, there's no x value given, like there's no number given here. So by default, x is x, x doesn't change. Okay, this is when we will take again the second function and without evaluating it, put it directly into f. What that means is I need f function first. And into this f function, wherever x is, I will have to drop in g function. That is called taking g and fusing it into f. Don't forget x was squared here, so that stays. And that's step number 1. And from here I have to evaluate this. But what is f? What is 4x plus 1 whole squared? A lot of us will miss on that. So always expand it and then do multiplication. Don't forget there was a 2 here, so all this boils down to, let me put this on the side, this was my side work, and minus will be distributed. Now the 2 needs to be distributed with everything. Minus 4x, and then this is 3. Combine what you can. 16x minus 4x. And I have fused the two functions. F fused with g is a brand new function. And just because of the power, I can tell this is a polynomial function. This is a quadratic function. It's going to be a parabola. So brand new function. What's the domain of this function? This is a polynomial function, and I'm not sure if you remember, but we only did two functions, poly and rational. And obviously this is poly. Poly is the nice smooth ones. They don't have any breaks, any holes, no asymptotes, no jumps, no cusps, no corners. They're the nice ones. Their domain is all real numbers, no breaks. So yay for a change, we have a very simple domain. Let me show you B now. I didn't do B. So on this slide, let's just do B, golf. And if you notice, I mean, all the difference between A and B is the switch of order, and that changes the answer completely. But you got to register again. Let me reiterate. X is not given. There's no particular value of X that they want us to use. So X stays as X. And then rules don't change. You have to take the second function and fuse it into the first one. So for that, I'm going to first write the first function. And then wherever x is at, I'm going to plug in g function there. I mean f function. See, the f function goes into g function. And distribute. And combine what you can. And if you've noticed, I have found g of composed with f, another brand new function. If you compare the two answers, the first function we got, which is f of g, this is g composed with f, just the order, two totally different answers. However, this one's still quadratic, and it is still polynomial, and domain is still all real numbers. All right, here is a math Excel problem that is from the homework. I'll do, let's say, any one of them. Let's say C. So f composed with f, and there's no x value given, so I literally have to take f. And if you notice for C, g is not even needed. And into f, I'm going to put f. And f function is 2x plus 4. So it's like the function is eating up itself. From here, distribute. And 4x plus 12 is f fused into f itself. Is another function. This is linear, if you remember. Ax plus b types and linear are also polynomials. No holes, no breaks, no nothing. Its domain will be all real numbers. All right, I'll go ahead and try A, B, and D. And I will continue. Okay, one last thing for 4.1 is to show that two functions are equal, two compositions are equal. First, register in your mind function f and function g. Okay, register that. The two functions given, one is called f, one is called g. They want me to show that f of g for any x value is the same as g of f for any x value. So I'm going to split my workplace. I'm going to do f of g here. So that means, and you can always put an x here, but that means you take the g function and put it into f. Fusion time. So obviously I need f function first, but then wherever I see x, I'm going to put g function into it, right? G goes into f. So negative half, oh, and more parentheses, there. So negative 2. So since we got to get rid of parentheses, I'm going to get rid of the inside parentheses first. The outside one stays. Negative half times x is negative half x, and negative half times negative 1 is half. Now I need to distribute, and since these two are different, I can't combine them, so all I can do is distribute. And then minus 1, and then don't forget there's a plus 1, don't forget that. There. Now you're probably thinking, where did I get the x from? Like if you multiply negative 2 and then the first one, I mean, half and 2, don't they cancel each other? And two negatives make a positive, it's just x, right? Anyway, 1 minus 1 is 0, so x. So f of g is x. Now let's do g of f. So I have to take f function and squeeze it into g. So let's write g function x minus 1. Okay, and where I see x, I have to fuse in what? I have to fuse in f function into it. And f function is negative 2x plus 1. Don't forget there was a plus 1, minus 1 there as well. Well, 1 minus 1 is gone, so I have negative half times negative 2x. 2 cancel with 2, negative multiplied is positive. So we have g of f equal to x as well, and I have proved that they both are the same. And in the next lesson, you will learn that when that happens, these two functions are inverses of each other. But that was my last example. Hopefully it made some sense. I'll see you in the next video.